chapter 21, right? We're talking about errors today. And when I say errors, I don't mean mathematical mistakes that you make during your test, okay? I mean errors that maybe you get a super unusual sample, and so then you make the right conclusion for your test, but then that's actually the wrong conclusion in reality. That's kind of the errors I'm talking about, right? So, for example, M&Ms, those are always the easiest portions. We did that sampling distribution model activity with orange M&Ms, 20%, right? Well, what if isolated incident one day, all right, they were in the factory and the orange M&M chute started just spilling out M&Ms, not to their 20% ratio, and there was about 6 bags that seemed to have been affected before they could stop it, but they're just M&Ms, so I mean, they're not going to waste the bags. So when we did our activity, I happened to have bought one of the bags, all right? Well then, function hypothesis test, I was going to test to see if the alternative with p is greater than 0.2, and I very well could have gotten this high, or this really, really low p-value, and would have had to reject the null hypothesis that p equals 0.2, because we have this really crazy, unusual p-value. But again, in real life, it was only 5 bags that were affected. So in real life, we shouldn't have rejected. Our tests, we made the correct decision with our tests, but in real life, that's not the correct decision. All right, so that's what I'm talking about when I mean errors. And there's 2 types of errors, and those Roman numerals are very important. Okay? So the first error, the null hypothesis is true, but we mistakenly reject it. The null hypothesis is actually true, but in our tests we reject it. All right? The second error, the null hypothesis is false, but we fail to reject it. All right? So those are 2 types of errors. Those Roman numerals are important because in statistics we give these some fancy names, and we call them type 1 and type 2 errors. They are called that for always, type 1 and type 2. Now, they may not show up about proportions, but I'm telling you with like 100% confidence that type 1 and type 2 errors will show up on your AP exam somewhere. It might be the multiple choice, it might be the free response, but they're probably going to ask you about them. So you have to know the difference. They're not going to tell you this is a type 1 error. You have to know that. When we start getting into other hypothesis tests, these concepts still stay the same. All right? This doesn't help me, but it says the book, so maybe it'll help you. It says one way to keep the name straight is to remember that we start by assuming the null hypothesis is true. So a type 1 error is the first kind of error we could make. All right? So if that doesn't help you, that's fine. It doesn't help me, but if it does help you, great. I've said it. So here's a nice visual, all right, for our errors. All right, it's a nice little box. So if the null hypothesis is true, 2 things can happen. We reject the null hypothesis, it's a type 1 error, or we fail to reject the null hypothesis is what we're supposed to do, and so that would be okay. If the null hypothesis is false, well, if we reject the null hypothesis, that's what you're supposed to do. And if you fail to reject, then that's a type 2 error. So it's a nice visual. I'm actually going to give you guys a worksheet today, and it has that on there, so you don't have to write that down. Okay? So if it helps you to see the visual, or if it can help you to remember them, if you recreated it somehow, and you have to know type 1 and type 2. All right. What we're interested in, though, is how often a type 1 error will occur. Okay? Now, this type 1 error happens when the null hypothesis is true, but we had the bad luck to draw an unusual sample, like the M&M. So if we're going to reject the null hypothesis, the p-value has to fall below our alpha level. So if our alpha level is 5% and we're going to reject, it has to be somewhere below that, 0.2, 0.02, 0.03. When the null hypothesis is true, that happens exactly with probability of your alpha level. So when you choose the level alpha, you're setting the probability of a type 1 error to alpha. So if my alpha level, or level of significance, is 5%, then the probability that I commit a type 1 error is 5%. If my alpha level is 10%, a probability of making a type 1 error is 10%, et cetera, et cetera. that's the only space in which we'd reject is underneath that alpha level. So it's the only probability that we would make the error, okay? If the null hypothesis is not true, we can't make a type 1 error. This only happens when the null hypothesis is true. That's nice. When the null hypothesis is false and we fail to reject it, that's a type 2 error. Now, the probability of a type 2 error is represented by beta. I'm only telling you this because maybe they'll show the symbol at some point. You won't be able to calculate the probability of a type 2 error, and this is why. So if the null hypothesis is false, right, and you fail to reject it, that's an error. Well, the probability of that happening is dependent on the alternative hypothesis, all right? And the alternative hypothesis is p is less than or greater than or not equal to, and that's not one specific parameter value. That is several values, and the probability would change depending on what that parameter value was. So you don't have to know beta, but they might say something about type 2 error being beta. It might come up a little bit later in chapter 21, but you won't need to know an actual value. They won't ask you that on the AP exam. And then if we want to reduce types of errors, okay, it would be nice because you don't want to make errors. You're doing this hypothesis test. You don't want to make errors. That would be a whole big ordeal if you make the wrong conclusions. But you really can't eliminate them, okay? Now, they aren't direct complements of each other, and I'll show you a picture tomorrow. But if the probability of type 1 error is a specific amount, and you reduce that, so you reduce your alpha level, which reduces the probability of a type 1 error, well, then you have increased the probability of a type 2 error. Again, they're not exact complements. But if you decrease type 1 error, you increase type 2 error. If you decrease the probability of a type 2 error, you increase the probability of a type 1 error. So they're always in this battle together, all right? The only way to reduce both types of error is more evidence or collect more data. That means you need a larger sample size. The larger your sample gets, the less variability there is, the closer it becomes to whatever the actual P is, the true proportion, and that is how you reduce error. That's the only choice you have. There's nothing else. We'll get into more of that tomorrow. But what I want to do now is I want to go do an example in context, because generally this is how errors come up. They ask you to do a test. They ask you about what a type 1 error would be, what a type 2 error would be in context, and then they ask you about the ramifications of those. All right, so this is what this asks. A clean air standard requires that vehicle exhaust emissions not exceed specified limits for various pollutants. Many states require that cars be tested annually to be sure that they meet these standards. Suppose state regulators double-check a random sample of cars that a suspect repair shop has certified as okay. They will revoke the shop's license if they find significant evidence the shop is certifying vehicles that do not meet the standards. Now, before we even do A, B, C, or D, we need hypotheses. They are not going to be the hypotheses we're used to because they don't give you any proportion, but we can write them in context, all right? Now, they're going to give you some claim. That's what's going to happen in your homework, too. They're going to give you some claim. Whatever your claim is the alternative hypothesis, and your null hypothesis is that it's the opposite. So in this case, the state regulators double-check a random sample of cars that a suspect repair shop has certified as okay. So they think that the shops are certifying cars that don't meet the standards. That's what the claim is. So our null hypothesis is going to be that the shop certifies cars that meet the standards. They do what they're supposed to. The alternative, then, is that the shop it's supposed to be not Y if there isn't. I misspelled that. Sorry. don't know. I don't know how to spell. I apologize. The shop certifies cars that don't meet the standards. That happens a lot. You're going to see one that says something and the other one says it doesn't. They're just opposites of each other. So you have two hypotheses. We're going to use those hypotheses to answer the questions. That's what we're going to practice with our homework tonight. So, on A, in this context, what is a type 1 error? Well, a type 1 error is when the null hypothesis is true, but you rejected it. So in this case, in part A, the null hypothesis is true, so the shop certifies cars that meet the standard. But we'd rejected that hypothesis, so the state regulators say that they don't. They say that they don't certify cars that meet the standards. They say that they certify cars that don't meet the standards. And that ends up, it said in the question, they will revoke the shop's license. So that was going to lead to the revocation of the license. That means they're going to lose this part of their business. They won't be able to charge people to check their cars. Okay? Now part B is different. Part B says, in this context, what is a type 2 error? In a type 2 error, the null hypothesis is false, but you failed to reject it. So in this case, the alternative is what was true. So the shop certifies cars that don't meet the standard. But the state regulators say that they certify cars that whoa. That do meet the standards, okay? So that's what it is in context. And we're going to practice that today in class and on your homework. Part C and D start talking about the difference in these errors. So in part C, which type of error would the shop's owner consider more serious? Well, if you were the owner of the shop, I would think that the type 1 error will be way more serious. I was doing what I was supposed to, but the state regulators came in and said that I wasn't, and so I'm losing my license. That means I'm losing my license for no reason, because I'm doing what I'm supposed to. So in that case, type 1 error is more serious. In part D, though, it says which type of error might environmentalists consider more serious? Remember, this is all about emissions to the environment. So if I was an environmentalist, I would think the type 2 error would be more serious, because that means that the shop is sending through all of these cars that don't meet these emission standards, which means there's more emissions in the air. But the state regulators say that they do certify cars, so they're letting them keep doing this. So that's what it is in errors in context. That's all you're going to do today, all right? You're talking about errors in context. You're going to write some hypotheses in context. You're going to write the errors in context. It's going to ask you about the ramifications of those. So what does that mean for each party involved? And then you're going to have to come up with an opinion about which one you think is worse. Okay? Now, in these, sometimes they're both equally as bad. You can't maybe make a stance. Sometimes one is obviously worse than the other. Okay? So it's up to you most of the time on your opinion which one's worse. Now, if they ask you specifically on this case on C and D about a specific party, well, then you need to think in terms of those people. Okay? All right, so that's what we're going to do today. We're going to be working on that in context.